Hello everyone, so this is my second lecture from the chapter Aldehyde, Ketone and Carboxylic acid. So in my last class we have discussed that when carbonyl compound reacts with hydrogen we get hydrogen. So this is an example of nucleophilic addition reaction actually, where this hydrogen act as a nucleophile. But for your syllabus, this mechanistic part is not important. Just you remember that this water gets eliminated from this hydrogen and you get what? Hydrazone. So similar reaction when this hydrogen is replaced by phenyl hydrogen. So you know this is hydrogen, NH2 is what? Hydrogen. So when one of the NH bond is replaced, when one of the hydrogen bond is replaced by phenyl, we call it as what? Phenyl hydrogen, right? Now when we place two nitro groups at 2 and 4 position, then we get what? 2,4-dinitrophenyl hydrazine. For example, you can number 1, 2, 3, 4, 5, 6. So you can see that at 2 position and 4 position nitro group is present. So this is what? 2,4-dinitrophenyl hydrazine. Also it is known as 2,4-DNP. In short form we call it as 2,4-DNP, and the name of this reagent is called as Bradish reagent. This is a very important reagent which is used for the detection of carbonyl functional group, right? So whenever you have a carbonyl functional group, you add this 2,4-DNP or 2,4-dinitrophenyl hydrazine, then here also from this reaction water will be eliminated. You can clearly see out the elimination of water and you will get this skip base types of product which is also called as imine. Now this product, the name of this product is called as hydrazone. As you have taken 2,4-dinitrophenyl hydrazine, you will get the product 2,4-dinitrophenyl hydrazone, which has an orange red precipitate. This is orange red precipitate. So you can tell that if any carbonyl compound is treated with 2,4-DNP and heated, then you will get yellow or orange precipitate of hydrogen, and in that case you can say that carbonyl group is what? Present, right? Now how to do this test? Let us explain it practically also. Suppose in your test tube you will take what? Your sample organic compound plus you add what? 2,4-DNP, right? Now when you will add 2,4-dinitrophenyl hydrazine and when you will heat, then you will get this orange red precipitate. Then you can tell that your functional group, that is your sample, contains this carbonyl group. And if you add 2,4-DNP to your sample and if you heat, if you do not get any orange red precipitate, then you can tell that no carbonyl group is what? Present. So this reaction is used for the detection of carbonyl functional group. Now you can tell that among this carbonyl functional group, which one will react? Among aldehyde and ketone? The answer is both will react, because aldehyde and ketone both belongs to carbonyl functional group, right? So this reaction, if you take with suppose aldehyde, you will get here aldehyde hydrazone. If you take here ketone, for example this ketone if you take, plus suppose if you react it with what? 2,4-dinitrophenyl hydrazine, here nitro, you will get the product as what? this water will be gets eliminated and you will have this product C double bond. Now you can see C double bond and that next N is there, right? Because water will go out, okay? But don't show in the exam. It is just for your understanding how to remember the product of the reaction, right? The other things remains the same. There is not too much difference, okay? So other part is remaining same. So just you have to remember that this NH2, this H2 you write in the left hand side, okay? Then you can easily detect the what? Product, okay? So this is, as I already discussed with you, this is called as Brady's reagent. So what test you will do for detection of carbonyl functional group? The answer is what? 2,4-DNP test or reaction with Brady's reagent. Okay, so let us go to the next slide. Now next, this is a very important reaction of aldehyde and ketone. This is called as aldol condensation, right? Now from the name, what we can guess about it, this aldol condensation. So aldol, the term al comes from what? Aldehyde, right? And the ol comes from what? Alcohol. So simply you can tell that aldol is a compound which contains what? Both aldehyde as well as alcohol as functional groups. But this is not always true, because this functional group may be also ketone. Ketone can also act as a what? Functional group, right? Then it is called as what? Even it is called as aldol, okay? If both aldehyde and alcohol is present, then it is also called as alcohol. And if ketone and alcohol is present, then also it is called as aldol. Now you can see clearly the product of this reaction. Now important thing is what? These reactions occurs when the aldehyde or ketone should have what? At least one alpha hydrogen in them. Now what is called as alpha hydrogen? Let me to explain. You can see here, if you write here, this is the functional group, this ketonic group is the functional group, right? Now when this functional group is what? Containing alpha hydrogen, these three are what? Alpha hydrogen, because with respect to this functional group, this ketonic functional group, the first carbon is called as what? Alpha, right? Now you can clearly see it contains 3 alpha hydrogen, right? So it is a what? Compound having alpha hydrogen. So these types of compound can react with another molecule of when both the aldehyde are same or when both the ketones are same, we get an aldol condensation which is called as simple aldol condensation, right? Simple aldol condensation, both the aldehyde are same, right? Then it is called as simple aldol condensation. Similarly, here we have taken 2 aldehyde, we are getting this aldol product, right? And if we take 2 ketone, then also we can get what? Aldol. But that will also simple aldol if both the ketones are same. Now let us discuss what is cross aldol condensation. Now cross aldol condensation, you can clearly see that here this is one aldehyde CH3CHO, this is another aldehyde, okay? So these both are what? Different aldehyde. This is called as what? This is called as acetaldehyde, right? CH3 CHO, clear? And this is propanol, CH3 CH2 CHO, right? So this is called as propanol. In IUPAC system, this is called as 1, 2, 3. It is what? Propanol. Because this aldehyde group is a terminal group, it always gets number 1 position, right? Similarly, this you can tell as what? 1, 2. So you can tell it as what? ethanol. So ethanol is the what? IUPAC name of this compound, and propanol is the what? IUPAC name of this compound. Now interesting thing is what? Here I inform you that this presence of alpha hydrogen is very important, right? Now if this is the functional group, with respect to functional group, first carbon is called as what? Alpha. Now you can see clearly here how many alpha hydrogens will be present in this case. Let us draw the structures with expansion. Then you will find that if this is the functional group, this group is called as functional group. First carbon is called as alpha. So there are how many alpha hydrogen? 3 alpha hydrogen, right? But in this case, this CH3CH2OH, CHO, how many alpha hydrogens are present? In this case, there are 1 and 2 alpha hydrogen, because this is the what? Functional group. First carbon is called as alpha. So there are 2 alpha hydrogens present, right? Clear? Now the thing is what? How this aldol condensation occurs. Okay. Let me to explain the mechanism of this reaction in briefly. So first what will happen? This CH3CHO, right? So this is called as what? This is called as what? Aldehyde, right? Now if you give dilute sodium hydroxide, then from this dilute sodium hydroxide you will get sodium ion plus you will get what? Hydroxyl ion, right? You will get both this. Now this hydroxyl ion can act as a what? Base, right? So this base can take up this proton and you will get what? A carbon anion. This electron will go here, right? So you will get a what? Carbon anion. What is carbon anion? When the carbon is having what? Negative charge, then we call it as what? Carbon anion, right? Now interesting thing is what? This carbon anion is again stabilized due to resonance. How? This electron can go to this carbon and this electron can go to this oxygen. So you will have a what? Resonance structures of like this. Here you can see this electron is residing at this carbon and this electron will come to this carbon. So they will make a what? Bond, and you will have the oxygen negative, right? So this is called as tautomerism, right? This is called as tautomerism. So this is resonance structure 1, this is resonance structure, resonantical structure 2. So this is called as the enol form, and this is called as the another isomer, resonance isomer, right? So this is called as keto-enol isomerisms. Now this carbon anion which is negatively charged, this can attack to a what? Another molecule of aldehyde or ketone. For example, suppose you have two molecules of what? Aldehyde, right? So here you can see that if you have 2 molecules of aldehydes, for example this is one of them, CH2, then CH3, this is propanol, right? Now from another molecule you are getting this what? Carbon anion, right? Here you are getting this what? This carbon anion. Either you are getting this carbon anion or you are having the enolate form, right? Now this carbon ion is having negative charge, so it can act as a what? Nucleophile. And in this compound propanaldehyde, you know, among this carbon and oxygen, oxygen is more electronegative than carbon. So this electron will go to oxygen, and if this electron is going to oxygen, oxygen will become what? Negative charge, and carbon will become positive charge. So this center is called as what? Electrophilic center, right? Now to this electrophilic center, nucleophile can come and attack, right? So this is what we call it as nucleophilic addition, which is the most common reaction in case of carbonyl compound, right? So you can clearly see that here H, then this ketonic group will come, and CH2 is coming to what? This carbon, right? This will become negative, and here you are having what? This CH2 CH3, that means this part and this hydrogen, right? Clear or not? Now next time what will happen? There may be somewhat hydrolysis, right? Because you are having what? Water from the dilute sodium hydroxide, water, right? Now this can take up a proton from water. This can take up a proton from water, then you will get this product HCO, then CH2, then what? COH, here CH2 CH3, and here you are having H. So you are getting the what? You can see, if this is the functional group, this is the ketonic is the functional group, first position is alpha, second is called as what? Beta. So if you have alpha and beta, you can see that beta hydroxyaldehyde, you are getting what? Beta hydroxyaldehyde. So this beta hydroxyaldehyde is the product in this case. Now finally, this beta hydroxyaldehyde can undergo elimination reaction. If you heat and if the base is little strong, then this water elimination is possible. How? This we can write this CH2, we can write like this also. If we can show one hydrogen here, then what? If the base is suppose strong, it can take up another proton, this will go here and this will go here. So there will be a what? Liberation of water. Then you will end up with a product which is called as aldol product, right? Here you will have what? CH, and here you are getting a double bond, CH2 CH3, right? And here you are having hydrogen. So you will get a product which is also called as alpha beta unsaturated carbonyl compound. Why? Because this is the functional group. With respect to functional group, first function is alpha, next first carbon is alpha, next one is beta. So this is alpha beta position, double bond is there, and here it is a carbonyl compound, so it is called as alpha beta unsaturated carbonyl compound. So you will end up with this product which is called as what? Aldol condensation, right? Now we are discussing about cross aldol. You can tell them how many products will be formed. Cross aldol generally leads to the mixture of product. How? Because this CH3CHO have 3 alpha hydrogen, so it can generate this what? It can generate this what? Carbon and ion. Then it will attack to this what? This part, and you will get one product. Similarly, you can also tell that this CH2CHO, from here also one proton can be abstracted, then it will form negative. Then this can attack with a what? Another molecule of what? Aldehyde. Another molecule of aldehyde it can attack. Then you will have another product. So in this way you can have a what? Mixture of product in cross aldol condensation reaction, right? So this is called as cross aldol. So What is simple aldol? When the two aldehyde and two ketones are same, it is called as simple aldol. And what is cross aldol? When both the aldehyde or ketones, at least in having one hydrogen in one of them, condense, then we call it as what? Cross aldol, right? So this is the difference between simple and cross aldol condensation reaction. Okay. So now let us go to the reaction where there is no alpha hydrogen. Then we will see that these kinds of reactions are called as what? Cannizzaro reaction. We will going to study in the forthcoming slides. Now right now you can see that. So what are the other type of reactions this aldehyde and ketone can show? So this is an important reaction. It is called as Clemmensen reduction. Now you know reduction means always we know that what? Addition of hydrogen is called as reduction, right? So if you add hydrogen in presence of catalyst, that is called as catalytic reduction, right? But here we can see that the reduction we are carrying out with amalgam. What is amalgam? When the two metal is mixed, then it is called as amalgam. So here zinc and mercury amalgam is used, and here HCl is used as the reduction source. Now what is reduction? As we already know that removal of oxygen is also called as reduction. Now you can clearly see this oxygen is going, and if the oxygen is going, then two hydrogen will come. Then it is called as what? Reduction. So what is Clemmensen reduction? When this carbonyl group is converted to what? This alkane. Then we call it as what? Clemmensen reduction, right? And here this zinc mercury HCl is used as the reducing agent, right? So this is the product for Clemmensen reduction. You can see we have shown different example. This is benzophenone. You are getting this product. Whenever you take propanone, this is propanone or acetone, you end up with propane. Whenever you take benzaldehyde, you will get toluene, right? This compound is called as toluene. When CH3 group is attached to what? Benzene ring, it is called as what? Toluene. So this benzaldehyde to toluene can be done with what? Clemmensen reduction. Now another interesting reaction is Olp-Kirchner reduction. Here also you can see the product is same. When carbonyl group is what? Reduced. The only difference is the what? Reducing agent is different. Here we have taken hydrazine, alcoholic KOH as the reducing agent. You can clearly see this is hydrazine, ethylene glycol and KOH. This combined mixture of this hydrazine and ethylene glycol can reduce this carbonyl group to what? Alkane. Clear? So you can clearly see here also this oxygen is going out and two hydrogen is coming. So this is also called as reduction, but it is Olp-Kirchner reduction, where the reducing agent is what? Alcoholic KOH and hydrazine. The mixture of alcoholic KOH and hydrazine is used in Olp-Kirchner reduction, right? And in case of Clemmensen reduction, zinc mercury HCl is used as the reducing source. Now let us go to the next slide. Now this is a very important reaction. This reaction is called as haloform reaction, or also it is called as iodoform reaction, right? Now what happened in this reaction is any carbonyl compound, if it has a methyl group, right? You can see clearly, you can see here is a methyl group is present. Carbonyl group having methyl group, at least one methyl group, when you treat it with halogen and KOH, it will form haloform. This product is called as haloform, right? And this halogen may be chlorine, bromine or iodine. So we can now give one example of haloform reaction when this acetaldehyde is treated with iodine and potassium hydroxide then you get a bright yellow precipitate of CHI3, which is called as iodoform, right? Here also we can see that when this ketone is treated with iodine and KOH, we get the iodoform. That is, this iodoform is this bright yellow. Okay. Now you can tell that what will happen to this system. This system also, this CH3 will be converted to CHI3, and rest of the things you can clearly see that it will be broken down and it will be oxidized. Let me to explain this reaction in details. For example, suppose if you have COCH3, right? This is a methyl ketone because this methyl group is present. So this is a methyl ketone. Now what is the name of this compound? It is called as benzophenone. Benzophenone. This compound is called as benzophenone. Now when this benzophenone is treated with what? Sodium hydroxide and iodine, first they will react to form a compound that is called as NaOI. First it will form NaOI. Next this NaOI will break down to form Na plus 1 oxygen. Now this NaOI, this oxygen, when it is coming out, it will act as an oxidizing agent, and this bond will be broken down, and this ketone will be oxidized to what? COONA, right? So you will get a colorless salt. In this part you will have a colorless salt, plus you will get this CH3 will be converted to what? CHI3. That is called as what? Iodoform, which is what? Bright yellow precipitate, right? Clear or not? So I have not shown the balanced reaction in this case. To make it simple, I have not shown the balanced reaction in this case, right? So what we come to know that this benzophenone, this bond will be broken down. As you can clearly see that this will be converted to sodium benzoate. This is a salt. So here one oxygen is adding. So this haloform reaction you can consider as a what? Oxidation reaction, right? Where this ketone or aldehyde is oxidized, okay, and you will get a what? Iodoform taste, right? So what type of compound shows these kinds of iodoform taste? The compound like carbonyl compound which has a methyl group, right, will show this kind of taste. For example, suppose this CH3CHO also, you can say it is a methyl containing group, or you can have any ketone, R I am replacing, both of them when it is react with iodine, and here we have shown with sodium hydroxide, you can have also KOH. You will heat, you will get what? CHI3. Similarly here also, if you react it with iodine and KOH, this will give what? CHI3, which is yellow precipitate, iodoform taste. Clear? But if it do not contain any methyl ketone, it will not show these kinds of taste. Okay. So next we go to this Cannizzaro reaction. So as I mentioned with you that this Cannizzaro reaction is shown by carbonyl compounds which do not have any what? Alpha hydrogen. So if any alpha hydrogen is not present, then these types of carbonyl compound will show Cannizzaro reaction whenever they are reacted with concentrated sodium hydroxide. So this is the difference between aldol and Cannizzaro. So in aldol, I discussed with you that alpha hydrogen is an essential condition for aldol condensation, and for Cannizzaro reaction there should not be any alpha hydrogen. So this is the difference between aldol and Cannizzaro, right? Now you can clearly see that this benzaldehyde it do not have any alpha hydrogen. Similarly, these also do not have any alpha hydrogen. So they can show these Cannizzaro kinds of reactions. Right. Now what is Cannizzaro reaction? This is nothing but I already mentioned you, this Cannizzaro reaction is an example of disproportionation reaction. What? It is called as disproportionation reaction. What is disproportionation reaction? I think you have already studied in class 11, right? It is an example of what? Redox reaction. What is redox reaction? The reaction where both oxidation as well as reduction occurs, right? But the interesting thing is here, this benzaldehyde you can clearly see is undergoing what? Reduction to form this what? Benzyl alcohol. And at the same time you can clearly see another molecule of benzaldehyde is undergoing what? Oxidation to form this sodium benzoate. So you can tell that one species is undergoing both oxidation as well as reduction. That's why it is called as what? Disproportionation reaction, right? Now you can ask, how we can tell, sir, one is oxidation, one is reduction? We can easily detect, because if you see the oxidation, this benzaldehyde was having how many oxygen here? One oxygen. But in the product you can clearly see two oxygen comes. So definitely it is what? Addition of what? Oxygen. Clear? So this is oxidation. Now you can tell that how we can tell this benzaldehyde is undergoing reduction? Same thing here. It is nothing but you can say addition of what? Hydrogen, right? Addition of hydrogen. How? Because here CHO was there, but here it is what? Another hydrogen is here. Two hydrogen is added, CH2OH. So two hydrogen is added here. So it is called as what? Reduction. Also I can show you here separately, right? Suppose this is a aldehyde. Now when two hydrogen is added here, you will get what? You will end up with a what? You will end up with a what? Here C, this O will take this hydrogen, it will form OH. Here another hydrogen, here this. So this compound is called as what? Benzyl alcohol. Clear? So this is called as Cannizzaro reaction. Right? So Cannizzaro reaction is shown by those aldehyde which do not have any alpha hydrogen. So another example of Cannizzaro reaction is this HCHO, right? You can write here HCHO, right? So this is also what? A compound, that is aldehyde, which do not have any alpha hydrogen, right? So this is a compound without having alpha hydrogen. So this can undergo also Cannizzaro reaction with concentrate alkali. So one benzaldehyde will be converted to what? Methanol, and another benzaldehyde will be one formaldehyde will be converted to what? Methanol, and another molecules of formaldehyde will be converted to what? Sodium methanoate, that is the salt. Let me to show it once again, then it will be more clear to you. So this is HCHO, right? So another molecule of HCHO, right? Now when they both react with concentrate alkali, then here this compound can be converted to HCOK, that is the what? Oxidized product. So we can tell what here? Oxidation.